Good morning, guys. Hope you're doing well. Hope you had a good weekend. I haven't graded your quizzes and tests yet. I'll try and do it either tonight or on Monday. I'm having some tech issues here. I'm not able to use Doceri because my Wi Fi connection at the hotel is really poor. So I'm using the recorder option in the notebook program, notebook software, and trying to see if I can use this to record and then send this across to you. Okay. All right. Anyway, congratulations. We are on to chapter 7, a week before the end of the term, exponents and exponential functions. And the first lesson is zero and negative exponents. Now, I'm pretty sure we've dealt with zero and negative exponents in sixth grade. Here's an example. Remember this number 4235.18, and what we asked you to do if we gave you a number like this and asked you to write it in an expanded form using place and value. So you write this as 4 times 1000 plus 2 times 100 plus 3 times 10 plus 5 times 1 plus 1 times 1/10 and 8 times plus 8 times 1/100th. Then we also asked you to write this in exponential form. 4 times 10 cubed plus 2 times 10 squared, and you can see how the value of the exponent decreases as we are moving down the line, just like how the location of the decimal point started moving to the left as you move down the number. Then you have 3 times 10 to the first power, and then you add 5 times 10 to the 0th power, and so the next logical exponent is 1 times 10 to the negative first plus 8 times 10 to the negative second. So this is 5 times 10 to the 0th power is the same as 5 times 1, because any number raised to the power of 0 is going to be 1, and we know that from 6th grade. And if you look at the number that's in red, 1 times 1/10, now 1/10 can be written as 10 to the power of negative 1. All right, so let's look at some properties. The first property is a zero exponent property. According to this property, every non-zero number a to the power of 0 equals 1. Again, we know that from 6th grade. And here are some examples. 5 to the power of 0 equals 1. Negative 7.5 quantity to the power of 0 also equals 1. Now here's something that we need to remember. Now there is a difference between raising a whole value to the power of 0, like we have here. One second. Right? Here the entire value is raised to the power of 0. But if you look here, the 0 only belongs to the 7.5, and the negative can be read as the opposite of 7.5 raised to the power of 0, and we should not have any confusion about that. So I want you to look at both these things and realize that you're going to have a value of 1 when the entire value is raised to the power of 0, as opposed to uh, something that's raised to the power of 0 and you're considering the opposite of that value, like it's here. All right, so the next property is the negative exponent property. And according to this property, for every non-zero number a and integer n, a to the power of negative n equals 1 over a to the power of n. So A to the power of n is in the numerator. It's not what I'm looking for, magic, but yes. Okay. All right. So a to the power of negative n over 1. And you can see that the numerator has now become the denominator and the denominator become the numerator. So the value of the exponent becomes its opposite. So a to the power of negative n equals 1 over a to the power of n. So here are some examples. 3 to the power of negative 4 is 1 over 3 to the 4th, and then you simplify it and write it as 1 over 81. But if you look here, you have quantity negative 7 raised to the power of negative 2. Um, that is not true. Okay, let me just change that very quickly. So if you have negative 7 raised to the power of negative 2, that's the same as 1 over negative 7 raised to the power of 2. Notice that only the value of the exponent changes to its opposite, not the sign of the base itself. That equals 1 over negative 49, which can also be written as negative 1 over 49. I'm sure you're wondering what happens when 0 is raised to the power of 0. What do you think? Is 0 raised to the power of 0, 0? Or is 0 raised to the power of 0, 1? Now, I want you to look at this pattern first. There's a second pattern that I'm going to show you in a minute. You know that any number raised to the power of 0 according to the 0 exponent property is 1. So 3 to the power of 0 is 1, 2 to the power of 0 is 1, 1 to the power of 0 is also 1, and following the same pattern, 0 to the power of 0 should also be 1. I want you to look at this pattern. 0 to the power of 3, which is nothing but 0 times 0 times 0, is 0. And if you follow that sequence, 0 squared is also 0. 0 raised to the power of 1 is also 0. And 0 raised to the power of 0 equals 0. Now, how can 0 raised to the power of 0 be 1 and 0? Okay. So 0 cannot be both values, and therefore 0 to the power of 0 is undefined. That leads us to the second question. What about 0 raised to the power of a negative exponent, such as 0 to the power of negative 2 or 0 to the power of negative 5? So if I had 3 to the power of negative 2, I can write that according to the second property, which is the negative exponent property, as 1 over 3 squared, which equals 1/9. Now if we change the base to 0, I'm going to have 0 to the power of negative 2, which equals 1 over 0 squared, which is nothing but 1 over 0, and you know that any number divided by 0 is undefined. So 0 raised to the power of 0 and 0 raised to the power of a negative exponent are both undefined. Isn't that cool? Okay, let's do simplify some expressions. So I have 6x squared y to the power of negative 3 z cubed. Now, the only thing that needs to be changed here is y to the power of negative 3. I cannot have a negative exponent, and therefore I'm going to change that into a positive exponent. And how do I do that? I rewrite that as 6x squared z cubed, and all those things remain unchanged. And y to the power of negative 3 can be written as 1 over y cubed, which gives me that 6x squared z cubed, the whole thing over y cubed. So you can see that the negative exponent in the numerator, when it comes into the denominator, becomes the denominator, changes into its opposite exponent value. What about this? 1 over m to the power of negative 5. Here you have negative 5 exponent in the denominator. What happens here? So I'm going to write this as a division problem. 1 divided by m to the power of negative 5. Now the moment you see m to the negative 5, you know what to do with it. So you're going to write it as 1 divided by 1 over m to the 5th. Which is, I'm changing the division problem into a multiplication problem. So I have 1 times the reciprocal of 1 over m to the 5th, which is nothing but m to the 5th. And m to the 5th times 1 is m to the 5th. So here's something that you probably already figured out. When a base switches from the numerator to the denominator or vice versa, the value of the exponent changes to its opposite. So in the first example, y to the negative third was in the numerator. When it became the denominator, the negative third became positive 3. Negative 3 became positive 3. Now in the second example, you have m to the negative 5 in the denominator, and the way to get rid of that negative exponent and make it into a positive is to move it to the numerator, and what happens is the m to the negative 5 becomes m to the 5th. Okay? Maybe one more? Negative 15a to the negative 2b cubed over 3c to the power of negative 4. Now here are a couple of things that I want you to keep in mind. First, to simplify any expression to a, well, your goal is to simplify any expression to a form where the coefficients are simplified. When you have negative 15 and 3 here, that needs to be simplified. And there cannot be any negative exponents in your simplified form. Okay, so what are we targeting here? Let's see. So I'm going to look at the coefficients, and negative 15 and 3 simplify to give me negative 5, which is somewhere here. Okay, I can't find it, so I'm going to write it in. Okay, so I have and then I'm also going to target the a to the power of negative 2 and c to the power of negative 4. This needs to become a positive, and the only way that can become a positive is if I move that to the denominator, right? And the way to make this c to the negative 4 a positive is to bring this up to the numerator. So when I do all that, I have negative 5, which is the coefficient. In the numerator, I have b cubed, that remains unchanged. I just moved the c to the negative 4 to the numerator, and that became c to the 4th. That over the a to the negative 2, which I moved to the denominator and is now an a squared. Okay? All right, so it's 3 to the negative 2 times a to the negative 1 times c to the negative 3 over d to the power of 0. All right, so tell me, what are we going to target here? I'm going to target that, right? I have to target that because that's negative. I'm going to target that because the exponent is negative. I'm going to target this also because the exponent is negative. And I'm going to target this because I have a 0 exponent that needs to be simplified. All right, so let's start with the 0 exponent. What is d to the power of 0? That's 1. Now what happens to the 3 to the power of negative 3? Negative 2, pardon me. That's going to come to the denominator, and it's going to be 3 to the second power. I'm also going to move the a to the negative 1 to the denominator, and it becomes a to the first power. And I'm going to move c to the power of negative 3 also to the denominator, and it becomes c cubed. So what do I have in the numerator? All I have in the numerator is 1. And this has already become 1, right? That's already become 1. So now I have 3 squared, which is the denominator, a and c cubed. Let's simplify this, and I have 1 over 9ac cubed. What if I give you values of a and c and ask you to evaluate this expression? Plug in. So I have 1 in the numerator divided by 9 times the value of a is negative 1, and the value of c is positive 2. So let's plug these things in, these values in, and I have 1 over 2 cube is 8 times 9 is 72 times the negative 1 is negative 72. So I have negative 1 over 72. Right? Now, these are by no means the most interesting problems. I'm sure you'll find plenty of more challenging and interesting problems in the textbook, but hopefully um, this made sense to you. And when you start simplifying expressions, um, things would fall into place in your minds. Okay? All right, have fun, and lovely connecting with you um, on YouTube or whatever media this comes through. Okay? All right, guys, take care. Make sure you copy down the notes. Bye.